I would like to start this video by showing the core mission of the project. As you can see in the LCD display, it is about the DIY learning of hardware and MCU programming with the audio Class D and hybrid tone control. Hi everyone, my name is Sheila and I will be helping Dandy to present the DATE project in conjunction with DR 100-watt concept project. I hope everyone is in good condition while watching this video.
You may ask, what is a DR 100-watt concept project? It's basically a learning platform for microcontroller programming, hardware design, modular board interfacing, simple project management execution, and a demonstration of how teamwork works and how to execute a successful project.
I really see the passion, he stated again, to resurface the core mission of the project for a new viewer that do not know or heard about the project. He then emphasized that this project requires an automated test, but while in the process there is a girl visited him. It's not me, I am sure of that.
What?
You want to go out?
No, I still need a lot of time so I can finish all this video first, okay?
Talking 3 of 2.
The question maybe is, why do we need an automatic test equipment for this simple project? As you may see, there's an LCD and it is driven by an intelligent microcontroller driven by the program. And in that program, there are bugs. Yes, there are. And with the help of automatic test equipment, I am able to catch those bugs and modify it. That's the beauty of having an automatic test equipment.
What Dandy is trying to say is that when the program is repeatedly executed, it may happen that some variable may overflow, or loops and go to command will crash the program. Using an AD or automated test equipment can help to catch the bug. So he developed the DATE project, an acronym which means DR 100-watt concept project automated test equipment. We can see him here developing the DATE concept, and what is amazing is that he wanted a collaboration to develop the DATE project.
If you are interested with this project, you can join me, of course. Welcome to join me, and we can make this project successfully.
Any one of you guys contacted him? Don't lose this chance. Let's hear from him presenting the ins and out of the project in a reliability test environment.
The upper diagram represents the reliability testing manually with a human intervention. And this tester here, or the test engineer, his name is Dandy. What he will do in here is that he will going to perform a test sequence like pushing the volume up or the volume down, or change the equalizer setting. And whenever he push any of these keys, there is a response from the DR 100-watt concept project. For example, he pressed the volume up and he can hear the strength of the music is increased, or he can also see the response on the LCD by going down to like a representation of increasing the volume. And then he will going to write the data into the data logger. After the sequence of tests, he will going to analyze the data and then make the results or conclusion. Now the issue is that this guy who have a full-time job here in China, he cannot dedicate himself to keep testing this project 24/7. So that is a problem for him. So here is the smart solution. By removing the human intervention and develop an electronic system, what we call it ATE. So this ATE is programmed to do a specific job to test the DR 100-watt concept project. What the ATE do is that it will perform a sequence of tests by electronically or mechanically switch on the push button, and then there is a response on the project. As it says, if there is an action, there is a reaction. So the reaction is that there will be an increase of a signal strength here, or probably change display on the LCD, or power on and power off. So we will be going to change the human hearing or human a verdict by making use of electronic sensors here. So that is why there will be a lot of sensors coupled into the DR 100 watt concept, like maybe temperature sensors, signal strength sensors, voltage, current, and then fed in back into the ATE, and the ATE with the program will log it into the data. The data may be an EEPROM, into the EEPROM or into the SD card. So I think this will be solve the problem, and that tester guy whose name is Dandy will be free from 24/7 testing his project. Let me show you my first ATE. And there you are. This is my hardware. I have here my ATE hardware. Let me reverse the camera and I show you what it's all about. Let's understand the systems. There are two parts. The upper part is the DR 100 watt concept project. I will call it the UUT. UUT means unit under test. The UUT composed of the control module, which is run by a microcontroller with 20x4 LCD display, and then a hybrid analog and digital tune controller and equalizer. And this one here is the Class D amplifier, but I did not populate all the components of the Class D amplifier, just wanted to make use of the volume unit, which indicate the strength of the signal from the tone control. The one below is called the automatic test equipment hardware. I will call it ATE, short for automatic test equipment. It basically composed of a mechanical relays, a controller, and a keyboard, as well as a signal source. This is the controller. So this is basically a control module, same as the one here, but a different program. And this program running right now is a demonstration to the technical reciprocity in Cebu City, the Philippines. Sometimes when I have the demonstration and a seminar about a microcontroller there. We've got the man-machine interface keyboard. We have here an MP3 player. This is used as a source for audio, sine wave, and real music. And these are relays. The one here is a mechanical actuator that will going to push the button instead of just pushing the button like this. We make use of mechanical actuators. And the one here is a relays that will power on and power off the UUT. And we have two power supply SMPS. The first SMPS in here is for the ATE, and the other one there is for the UUT. So that's the system that is working right now. Let's see how it works actually. And the ATE is not yet started, also in the standby mode. Let's see. I'm going to start the ATE function right now by pressing this button. And DR100 concept ATE, execute ATE testing. Put the UUT in active and says power supply on, turn on the system power supply. And there you are. You can see the volume is increasing toward 0 dB is maximum volume. There you are. And you can see the VU meters indicates maximum volume in there. Focus please. Okay, let's see the actuators. Just watch the actuator. And there you are.
Hey guys, I am still here enjoying watching. You probably can see the manually build hardware. That's one hell of a DIY stuff.
I think that you have now an idea what the ATE does. It's basically the one who is testing the UUT here without the human intervention. Instead of me, the one who is accessing the volume up, the volume down, selecting the music environment like rocks, pop, jazz, classics, accessing the menu and some up and down here, and watching the display. It is the ATE that doing that, and it can be programmed to do that 24/7 or 1 year or 2 years.
Congratulations! Indeed a successful project. What make it more successful is the shareware idea, where Dandy used this platform to conduct seminar to universities, showcase at the Manila Maker Fair, where he got his break and sold the solution to a foreign university. He'd then keep discussing with people with interest in the test automation, programming, hardware, audio, basically maker with interest to any interested stuff. He interviewed Mr. Kevin Norma, an American known as the Python guy, for he is pioneer and obsessed in Python programming.
Right guys, who tell me about Fortran? It is Fortran.
Yeah, so I was 10 when Fortran first came out, like 1958.
1960. Okay.
Yeah, and in the 60s, there was a lot of academic investigations about how a language should be structured.
You know, I'm really interested to learn something that I've never learned before. So I was with Kevin just discussing about how we're going to program a robot or something about robotics or automation in Python.
I'm looking at this box here, and it reminds me of the box we had when I was doing geophysics in the 1970s. We had all of our...
Yeah, come on. I can imagine 70s, right?
But the same box.
All right.
And we had our electronics.
All right. Yeah.
But you really have done a job here.
Okay.
I'm
Thank you.
very impressed.
That's one hell of a discussion talking programming language like Fortran, COBOL, BASIC, C language, Arduino, robotics, and more and related to the project test automation. That should be fun, don't you think, guys? He promised Kevin Normal that he will going to make a solution for Arduino and Python programming with the same idea. His finale on this project declared of his intention to start the same project on test automation.
As you can see, I have a working systems of hardware and software right now based on the Intel 8051 solution, but I'm not going to stop there. As I said, I want to make use of Arduino as a solution to bring me a better ATE than what I have right now. As my friends told me that Arduino is a system of hardware, software, plus the community, and we've got a lot of hardware available in the market, and I want to try the hardware. With the busy schedules in real job, I want to leverage the available hardwares in the market, the shields, breakout boards, and other Arduino hardwares to possibly shrink the hardware development and software development from the 12 months that I have it here. The components are manually hardware into the universal PCB. There is a 12 months development behind PC scheduling work. I wanted to make that 12 months into possibly 2 months, can be, and or even 1 month. That is attainable, I think, and doable. I ask you, what I have done so far is what is it used for? Well, that's what we learned from the industry, that the product should be tested for the power and off for 1000 cycles.